Good evening, everyone. Good evening. This is Teacher Miu from Think Academy Singapore. Good evening, everybody. So today we will have the lesson 3, geometry. So for the geometry, actually is a very difficult one, right? It's quite a very difficult one. So how can we do it? Let's just start with Teacher Miu, and we will start at 7. So if you were here, please go to 1 and let me know. Yeah, please go to 1 and let me know you're here with Miu. Yes, if you have the book with us, that would be better, because today we are having some of the questions from the booklets that we have for primary 2, the math modular challenging, and we are coming to the module 3, which is about the geometry. So everybody, please get ready. If you are here, please let me know. Thank you. I can see some of you got 1 here. So you can comment 1 and let me know you're here with us. All right, so we are starting soon. Let's go. All right, before the start, let me just go through what we are having for today. So today we are having the geometry. So for the geometric here, right, we have 4 very important topics, which is about the equation, equal division of figures, which is on your page 20. And then also we will talk about the multi-perspective observation of 3D figures. They are very, very common topics in this model. And then also we will have the nets of 3D figures and also the 3D coloring problems. All these topics are very common topics in both competition and GEP. So please get ready. And before this, I also have 2 QR codes to share. One is from Teacher Miu myself. Okay, if you're interested in on our online classes, you can just scan this QR code and go to Miu. If you're interested in our in-person class, you can just scan this QR code and go to Teacher Apple. All right, once again, today we are talking about the geometry, including the equal division of figures and the multi-perspective of observation of 3D figures, and also the nets of 3D figures, and also the 3D coloring problem. Are you ready? If you are ready, please press 6 and let me know you are ready now. Yeah, you can just key in 6 in the chat box and let me know you are ready, and I will just get started. So here we go, Githia. Thank you a lot of you. So here we go. Now let's come to the first topic. Is about the equal division of figures. First thing first, very easy one. This is not the question within your booklet, but please try to divide this figure into 6 equal and identical parts. Very easy one, right? First thing first, let me just explain. What does it mean, equal and identical? Equal means they must have the same size. All right, the size must be the same. It cannot be like, say, one with 1 square and the other one with 3 squares. That's not equal. And for the identical parts, actually it means identical, they must have the same size and the same shapes. That means if they are all rectangle, they must be all rectangle. It cannot be one with a rectangle, one with a square. So they are not the same. So if we are doing so, how can we just divide this figure into 6 equal and identical parts? Please try. Actually, we have many possible answers, right? It can either be like this, all right? 1, 2, 3, 4, 5, 6. And we still have many different ways, all right? For example, I can also do like, say, 1, 2, 3, 4, 5, 6. All right? Many ways to go. But what about this one? Now we are coming to a very tricky one. For this one, how can we divide this figure into 6 equal and identical parts? Now I can give you 30 seconds to think about this. How to do so? You need to divide it into 6 equal and identical parts. So how can we do that? Is it easy for you? Now this one is trickier now, right? Because now you look at this one. This one is different from just a regular one, just like what we did. It's not regular. If it is not regular, so how can we do so? Okay, so now let's come to the one very important method for doing these dividing figures. Step 1, we need to know altogether how many smaller squares are there. All right, so let me count it for you. They go 1, 2, 3, 4, plus 6 and 10, all right, and 10 and plus 8, altogether there are 18 smaller squares. If we want to split it into 6 equal and identical parts, can you tell me each piece, how many little squares should there be? When you have altogether 18 tiny little squares, you need to share equally into 6 equal parts. Each part, there must be only 3. Great! There must be 3 little squares. If so, we need to consider about the shapes. That means with 3 little square, what would it look like as 3 little square? Okay, first thing first, it can look like a row with 3 squares like this, right? So let's see whether can we just split it into, put 3 squares in a row like this. Is it possible? Not really, right? It's like this one, all right? If you will do so, it's just like 1, 2, 3, 4. Hey, what about the rest? It doesn't make sense, right? Which means we cannot make it into a row because it doesn't make sense. This one doesn't work. Then you might say, Mew, actually we can do it in a horizontal way like this one. Hey dear, this one is just the same as a row. They are the same size. And also, it's not possible. Let me try for you. Let's say 1, 2, 3, 4, 5. Excuse me, and excuse me. It doesn't make sense, right? If it doesn't make sense, which means it is also not possible, no matter it is a vertical one or a horizontal one. If so, with 3 squares, what else shape can we have? Any idea? Actually, we can also make it a L shape, right? Like this one. An L shape like this. If we are making an L shape, is it possible to split it into 6 identical parts now? Now it can be like this. 1, 2, 3, 4, 5, and 6. That's how we can just split this figure into 6 equal and identical parts. That's quite easy, right? This is a very basic question for split the figure into identical parts. But then, all right, we are coming to a more difficult question like this. Now we need to divide the below figure into 3 equal parts with the same shape with all the grids completed. And each part must contain 1 circle. Can I just randomly split them into the part? No, why not? Because each part must contain 1 circle. But don't worry, we can still use the same method we just talked about just now. Let's say how. First thing first, we will know that altogether, how many smaller squares are there? So can you find out how many smaller squares are there? If you have the booklets with you, actually, this is the booklets on our booklet, book A. This is our book A booklet and it's on your page. Let me just go to you. All right, it's on your page 20. Yeah, our booklet page 20. So please, if you have the booklet with us, so please open your booklet and go to page 20. It's on your book page. The question is not on your page 20. Is it all right? So let's try this question. Is that right? If it is not on your booklet, it's all right. So we can just do this question also. Yeah. Altogether, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares. If you want to share it into 3 equal parts, that means each part should be how many squares? It should be 12 divided by 3 to get 4 squares each. If you have 4 squares each, so we can consider about the shape. In Mew's class, Mew talk about this. With 4 squares, what shapes can we have? Do you still remember? In Mew's class, Mew talk about this. With 4 squares, actually we have 1 word for this. Actually, that is Tollize, right? T-O-L-I-Z. Tollize. With Tollize, actually, there are 5 different shapes with 4 squares. For example, T shape. It's like this one, right? We can do a T shape with 4 squares. And also O. That means the O shape with 4 squares. And then L. That means the L shape with 4 squares. And then with I, that means all the way 1 row with all the way 4 squares. And also letter Z, that means the Z shape with 4 squares. So Tollize, they are all the possible shapes that we can have with 4 squares. Then let's try. Let's try T shape. Is it possible to do it in a T shape? It doesn't really make sense, right? No way. So T shape is not possible. So T1, no way. What about that O shape? Let's try. 1, 2, not possible also. That means O shape, also not possible. What about L shape? Let's try. Does it make sense? Does it make sense? It doesn't make sense, right? If so, then let's go to the I shape. Let's try there, let's try. Does it make sense? Not really. Now, finally, we come to the last possible one, which is the Z shape. Is it possible? Let's try. Yeah, why Z shape? Oh, let me show you. Look at the Z shape. Can I just do like this? This mu is still not possible. Rotate the letter Z like this. Ta-da! So this is the Z shape. And does it match the question? Because the question requires that each part you must have one circle. Yes, we have. So this is how we split the question, split the figure into the 3 equal parts with each part one circle inside. Very easy one, right? So it's like the total, and then to find out each piece how many squares, then consider about the shape it can be. Don't forget, if the question requires us, like say you need to have circles inside, then you need to make sure that each part must be the circle inside. One very important tip is we can just split from the corner or the special part like this. Alright, actually it's quite easy, right? Once it is done, I would like you to try the question on your booklet, which is, this question is on your booklet now. This is the question on your booklet, page 21. If you have the booklet, please go to page 21 and do it by yourself. And later, please tell me your answer. If you don't have, you can just take a look at the screen. Alright, it says split the following figure into 4 equal parts of the same shape. Each part must contain a star. What would each piece look like? So for this question, I will give you 1 minute to try. We'll give you some tips. Tips 1, go for the total first. And then tell me each piece, how many squares are there? And then don't forget, after that, you need to consider about the shape. So how would it be? Please try. Okay, I'll give you 1 more minute. All right. Here you go, 1 minute. Please try by yourself. If you have your answer, key in the chat box and let me know. Ooh. But that's not the answer. Not really, Michael. We can try again. There's one very basic thing. That A definitely not the answer. Cool. I got different answers from you now. Alright, so here we go. Yeah, great. I have many of you got the correct answer. So here we go, dear. Let's just go and try with me. Step 1, at least we need to know, right? At least we need to know altogether how many tiny squares are there. Like say for this one, altogether there are 5 fours. So there are 20 squares. If we need to divide it into 4 equal parts, that means each part it should be 20 divided by 4 to get 5 square each. If it is 5 square each, A definitely not the answer, right? Because there are 4 squares only. If there are only 4 squares, definitely not 5. So this one, no. Let's go to B then. For B and C, yes, they got 5 already, but you need to consider about the shape. Is it possible to go to a long L shape? Let's try. If I go to a long L shape here, what about this part? Does it make sense to you? No way, right? Alright, so long L shape doesn't really make sense. Then let's go to C. If we are going to C like that, how can we just cut them into such a part? It should be like All right, you will find out that only C is possible like this. Right, just like a thumb up, like this one. And ta-da! Which makes the answer C. All right. So once again, when we are doing such a question, don't forget we can follow this order to find out altogether how many squares are there. And if we divide it into 4 equal parts, so it should be each part how many pieces. After that, don't forget to consider about the shape and read the question properly. All right. Like say for this question, each part must contain a star, so it can be only look like this. Is it very tricky for you guys? Not really, right? This one is so easy. Anyway, let's continue to the second topic. It's about the multi-perspective observation of 3D figures. So that means we need to look at the cubes. Now guys, let's take a look at the first thing first, alright? Before we look at the cubes, let's take a look at this one. If Mew was just standing in front of my school bag and the suitcase and my bottle, what would it be like? Would it be A or B or C? Please key in the chat box and let me know. If I stand at the front, it will look like A or like B or like C. This one is quite easy, right? Yeah, this one definitely starting from the front. I can see the school bag. I can see a part of the suitcase. And also I can see the bottle, which is supposed to be like B. So B is actually the front wheel of the things. And continue. What about next one? When Mew is standing to its left, so this is the left wheel, how would it be like? It would be like A or like B or like C. What do you think? Right. Alright, please key in the chat box and let me know. It should be like, yeah, there's a small mule. That's why you can see me, right? So it should be, yeah, great. So at the very left, it should be the suitcase, right? And from the left all the way to the right, it's just like going to the front, right? So you can see this part of the school bag to the right of the suitcase. And also, can I see the bottle? No, the bottle was covered by the school bag and the suitcase. So it would look like A. How comes I'm looking at from the left? So it must be like this one, all right? So it's at the left, it looks like this. What about if Mew is standing in the sky? Now Mew is flying in the sky. So how would it look like when I just go all the way down at the bottom? So what can I see then? It should be, great. This one is quite obvious, right? When I see it from the top, so from my view here, I can see at the bottom, this is the top of the school bag, and then the top of the suitcase behind it, and also the top of the bottle. So this is what we call as the top wheel. Now these are the 3 wheels of the figures. If so, now let's take a look at this question. The question asks, the following figure looks the same when observed from the front, from the left, or from the top. Now guys, please try by yourself. Yeah, I can give you 1 minute for this question. You need to consider that for each of the faces, how would it look like? And then all these 3 figures would be the same as from the any idea? Oh, really? Seriously? Not really. Not really. I got some wrong answers. Not really. Please try your best. Yeah. Really? Seriously? Okay. Let's just Mew just coming back. All right, Mew just coming back with you. So let's start from the front wheel first. From the front, how would it look like? Let me show you. From the front of the first one, it will look like this. You will see the front of the figure with this one. So there should be at the first level 3 squares. And then at the top they go 1 more square. It should be like this as the front wheel. And continue. For this second one, the front wheel will look like this. Because you can see the front of the figure, right? So it should be like this. They are already not the same. So how comes it's from the front wheel? Okay, luckily nobody chose A, which means no. Alright, not the front wheel. What about the left wheel? That means you see it from the left. Will it be the same? Alright, let's take a look at the left. At the left, starting from the back, there will be this face, and then this face at the back, which will be 2 squares here. And then going to the front, you can see this face also. So this would be 1 more face like that. From the left of this one, again, you can see this face, and at its bottom, another face at the bottom. So it will be 2 squares at the back, and then there will be 1 more to its front. So it looks like this. And continue. What about this one? From the left, as from the back here, you can see 1 on the top and the other one here at the back, which means at the back here there are 2 squares, and also there will be 1 more to its front. So they are the same, which makes the answer B. Then I say, Miu, I think C is also correct. Okay, let me do the top wheel for you. From the top, you see it would be like looking at these 3 faces at the back, and then there will be 1 more to the front, which is like this. For the second one, the top one, you can see 1 here, and then another 3 next to it. Actually, it would just look like a square, like this one. And continue for the last one, is like this one is the top wheel, which will look exactly the same as the first one, but then the second one is not the same, which makes the top wheel not possible. So the answer for this question is B, the left wheel. Alright, this is one of the very, very common topics that we might see in the competition, and it will just look like this. They don't need you to draw out everything, but they need you to try and to choose the same wheel, like this one. Alright, after that, what about the next one? It's about the nets of 3D figure. This one is also very tricky, but it's also a very common topics in competition and also GEPs. But before this, we need to understand how would it look like for a cube. So let's go. Yeah. Let's go to the crazy cube. This is one of my favorite sections. Every time we talk about the cubes, it's a very, very funny one that I need to use my son's toy. As you see, this is a cube, right? Okay, let me show you a cube first. When Miu decided to cut it open, I will use my scissors to cut and cut it open. When I cut it open, I will just get the nets of the cube. So how would it look like? Let me just cut it open for you. When I just open its head, and then I open its bottom, and then I cut it at the side, as you see, right? I open it, right? I cut it at the side, and then I open it. Okay. This is one net of cube, like this. And you see, this is the head of the cube, and the body of the cube, and the bottom of the cube. So which makes it 1, 4, 1. When I fold it back, we can get a cube again. Right? So this is what we have as the first possible combination of the nets of cube. Any other possible way? Okay, let me cut it for you. Again, I open its head. Again. And then I open its bottom. Again. And then this time, I do not cut next to the head. I do not cut next to the bottom. I cut next to it, like here. This way. So I cut it and open it. You see? This is another net of cube. Sorry. It should be like this one. Like this one. It's another net of cube, but the same as the 1, 4, 1. Right? And when I go it back, now this time I would like to cut it in another way. So this time I open the top here again, but then I open the bottom here. And I open it. This is also 1, 4, 1. One head, 4 body, and 1 button. Right? Can you just think of the last possible way? How would it be? Okay, let me just do it again for you, alright? So again, I open its head on the top, like this. And then I open its bottom to another side, like this. Here. Again. So I will just open it from this side. So how would it look like? Let me just open it here. This is also another net of cube. As you see, 1 head, 4 body, and 1 button. So it will just be like this. 1 head, 4 body, and 1 button. As it still can be like this, and also like this. Still like 1 head, 4 body, and 1 button. For this one also, 1 head, 4 body, and 1 button. Later you will know why Miu need to emphasize on this, because this is very important. You need to know where is the head, where's the body, and where's the button. Let me show you some video about this, alright? So let's just watch. As you see, 1 head, 4 body, and a button. 1 head, 4 body, and the button. This one also the same. It's also like 1 head, 4 body, and 1 button. Same for this one, the head, the body, and the bottom. Also the head, the body, and the bottom. So this is what we call it as the 1, 4, 1, which is 1 head, 4 body, and 1 button. Apart from 1, 4, 1, we also have different types. For example, this one. Now again, it's still the cube, alright? Miu still have the cube again. Miu still have the cube, but this time I don't want to cut it here. I want to cut it from the side, like this one. Like this one. So when I cut it from the side, how would it look like? Okay, Miu show you the cube first, alright? Now I got a cube, and I decided to cut it from the side like this. First, I take out its head, take out its side, and then take out its head. Yeah, should be this way. I take out the head, and then I go to the top, and I cut it from the top like this. Ta-da! And then I take out the bottom also, and then I open up. This is also a net of cube. But let's take a look at this one. This one is quite different from just now, because now how many heads we have? We have 2 heads. Is it possible that for 1 cube you have 2 heads? No way. So actually, who is the actual head? Oh, let me just go back for you. When I just go down, the blue one is the actual head. But what about the orange one? Is it the real head? No, this one would be folded down as a part of the body. Let me show you again. This is the body part and go up, and then when you go all the way up, it's actually the head and a part of the body. How you find out what is the real head? Actually, guys, don't forget, if these are the body, your head must be connected with your neck to the body, right? So the real head must be the one connecting to the body. So this is the real head. And for this one, it's actually folding down as a part of the body. And this is the real button, right? If so, let's continue. All right, let's continue. Then we continue with another possible one. Again, we have 2 heads, 3 body, and 1 button. Is it possible? No way. We only have 1 one real head which should be connected to the neck like this. And this one is actually the, yes it is actually the body. And also with this one, a real head which is connecting to the body, and this one is actually the body, you fold it up. And this is what we call as the duck shape, 2, 3, 1. You see two heads, 3 body, one is going to the top here, and also 1 bottom, 2, 3, 1. Let me show you the video how we do it. Well done. That's not the head, right? You see the 2 head, right? One is the real one and the other one is actually the body folding down. Alright. So this is what we have as the 2, 3, 1. You need to know which is the actual body and which is the actual head. Apart from the 1, 4, 1 and 2, 3, 1, we still have 2 more, which is like this, which is the 3, 3. You might think, Mew, this is crazy. 3 heads and 3 body and no bottom. Oh guys, you need to know actually where is the bottom. Let me show you. Now you see, this is the body, and when it fold down, this is the real head connecting to the body. And what about this one? Yes, actually this is the what? This is actually folding down as the body. But what about the last one? Yes, okay, let me show you again. It would just see, it fold down, and become the bottom. So as you can see, actually, this one is actually folding down, and it would going all the way to be the bottom. This is the crazy thing. This is the crazy thing. You have only one correct head, which is connecting to the body, and this is the fake head, which is actually the body. And when you fell down, this part is actually the bottom. This is 3, 3, 3, which is quite crazy. But anyway, apart from the 3, 3, 3, we still have one more crazy one. It's called 2, 2, 2. That's like the stairs, the stair shape. This is the craziest one. Then you might see that we have 2 heads, 2 body, and 2 bottom. Does it make sense to you? No way. Definitely there would be only one real head which is connecting to the body, and this is actually the body you fold down. What about the bottom? Yeah, actually the bottom is the same as the head here. There is only one actual bottom connecting to the body, and this is actually folding up as the body. Let me show you like this. Alright, as you see, it's quite crazy, right? You have 2 heads and 2 bottom. How comes? Let's see. The head one we can easily understand because it's actually folding down as the body. But what about the real bottom? You see this too? Which is the real bottom when you fold down here? Or actually the one connecting to the body is the real bottom. And this one actually will be folded up as the body. Then you might say, Mew, why you keep telling us about the body, the bottom, the head, the body, the bottom, the head? Because there is one very important technique about this question. How can we do it? Okay, let's take a look at this question. Now you see, if I just open the cube, right? There would be 2 faces connecting to each other, which we would call them the neighboring face. Okay, let me show you. When I open the cube here, you see, when they are connecting to each other, they are the neighboring face. Neighboring face. Apart from neighboring face, they will still what we call as the opposite face. What does it mean? Let me just show you with this. We can see the blue one and another blue one. They are opposite to each other. So when I open it, you would find out that they are the opposite faces. Would they be connecting to each other? No. You must skip one to its opposite face. There must be someone next to it. They might say, Mew, why you rotate it? Maybe they will connect to each other. Okay, let me just rotate it for you. I rotate to this part. Are they connecting to each other as the opposite faces? No. Okay, I keep on rotating. When I open here, Will they connect to each other? Also no. So the opposite faces would never touch each other. Would never. Why we need to emphasize on this? Let's take a look at this one. Now I want you to take a look at this net. Alright, this net of cube. Can you tell me the opposite of face 1 is actually what? Is it 2, 3, 4, or 5? Please key in the chat box and let me know. The opposite face of 1 is actually... this is crazy, alright? Let me show you. If this is the net of cube, 1 is the what? Well done. 1 is the head, right? And the head is opposite to the bottom. So if 1 is the head, it should be opposite to the bottom, and the bottom shall be, well done, the bottom shall be 6. So 1 is opposite to 6, which means they would never be next to each other. Continue. Now we have 1 is next to, opposite to 6. What about next one? 3. 3 is opposite to, let's take a look at this. This is 3. Will 3 be opposite to 2 or 4? Well done. 3 would definitely not be opposite to either 2 or 4 because they are the neighboring face. The opposite faces must be skip 1 to it, which is 5. Now what about 2 now? Alright, or we say the face of 4. Who is the opposite to 4? That must be only 2 only, right? We skip 1 to its opposite face. That's how we can do this. Why you need to keep asking about the faces, the opposite faces, alright? It is because we need this to do this question. Again, the top is always opposite to the bottom. And as the body part, you need to skip 1 to its opposite. Okay, let me show you again. As the body part, you must skip 1 to the opposite because the opposite faces would never connect to each other. You must skip 1 to the opposite, skip 1 to the opposite. If so, let's take a look at the question. This is the question on your booklet, which is on your book, page 23. Which cube can be made from the nets given? Then you will see this one, right? Every time you see the crazy shape, every time you see the nets of cube, please analyze who is the actual head and who is the actual bottom, and how would it look like on the cube. First thing first, who is the actual head? The triangle or the circle is the actual head. Definitely is the circle, right? Because the circle is connecting to the body, which makes the circle the actual head. And the actual head should be connecting with the actual bottom. Who is the actual bottom? Is it the plus or the star? Definitely should be the plus, which connect to the body, right? So actually the circle is opposite to the plus. Then what about the triangle? What is the triangle actually? The triangle is actually the body, right? Like this. So this is the body. And what about the star? The star is actually it's actually also the body. If so, who is opposite to the triangle? Is it the heart? No, you must skip 1 to the opposite, which is the square. So for the rest, the heart is opposite to the star. If so, can you tell me which one cannot be like that? I will say, which one can be made of this? Can A be the answer? Why not? Because the triangle and the square, they are the opposite faces. Can they be next to each other? No. That's why A cannot be the answer, because the triangle and the square must be opposite. And continue. What about B? Can B be the answer? Also no, why not? It's for the same reason, because the heart and the snow, they cannot be with each other. No way. What about C? C is the answer. Okay, how we fold it? You just focus on the front face, which is a plus. Then you fold down the square. You can see the square is on your top. And then look at the star. The star here will be folded and make it to its right. So this is the star. That's how we get to the answer C. So don't forget, always analyze how can we do this, alright, by finding the opposite faces, which is quite easy. That is for the same thing. This is for the same thing, guys. When we can see the star, the circle, and the square, these three faces can definitely not be opposite to each other, which means, is D possible? No, because the circle and the star, they are opposite. The circle and the star, they are neighboring with each other of the cube, which means D, not possible. What about C? C is also not possible because this is the head and this is the bottom. They are the opposite one. But look at the circle and the square. They are the neighboring face, definitely not the same. But what about A and B? Which one is the correct one? Please try by yourself and submit the answer by scanning the QR code. As we are running out of time, actually, I still got something to share with the 3D coloring problems. With the 3D coloring problems, there is one very important method I will just go to you, is about finding the unpainted faces. For the unpainted faces, actually, we can use altogether how many faces for all the cubes minus the painted faces to find out the unpainted one. If you want to know more, you can just contact Teacher Miu. I can just explain more to you. Alright, so this is for the 3D coloring problem, is also one of the very common topics, not just in P2 competition, but also in P3 competition and GEP. So everybody, for this topic, if you have any problems, you can just go to Miu, alright? After that, for the future plan, I'm so sorry for the overrun for today. After today's, we already finished all the 3 sections. So after these 3 sections, if you are interested in the SESMO competition mock test, you can just scan this QR code and go to our mock test. This mock test would be an authentic mock test with altogether 25 questions, and it will be bound in the class already. Once you sign up for that, there will be one lesson which is on the January of 17th of 2025, and then it's a Friday, which is at 7 to 8:30. There will be an analysis to each of the questions that we did in the SESMO mock test. So this is, we have the original price of $19 for this test and analysis. But for the current students, which is from Miu's class or Apple's class or Sherlyn class or Jamie class, or any of the current students, no matter you are in P1, P2 or P3, it is free. So there will be voucher inside your account already. If you are a new student, so currently you are not in Think Academy as a student, you will get a $10 voucher for a Christmas promotion. The promotion will be end by the 24th of December. So if you are interested in the promotion and also the mock test, please feel free to contact Teacher Miu or Teacher Apple. Alright, so this is the future plan for the SESMO competition. And thank you so much for all the 3 sections we have been going through for the past 3 days. If you are interested in any of the annual plan or any of the preparation, no matter for SESMO or GEP, please feel free to contact Teacher Miu and Teacher Apple. Thank you so much. And again, if you want a voucher and if you want a promotion, please feel free to contact me or Teacher Apple for that. Thank you everybody, and hope I can see you guys in the next year and also for the preparation of the competition. Bye bye guys.